All right, let's dive in. Today, we're going to decode the language that powers, well, pretty much everything, from your social media feed all the way to self-driving cars. So let's get right to it. So I know what you might be thinking. Hold on. Algebra? Like school math? For something as wild and futuristic as AI? And you know what? That's a totally fair question. A lot of people wonder why we have to go all the way back to basics for a field that feels so advanced. Well, the answer is actually pretty simple. Algebra is the language of AI. It's not just a tool, it's the fundamental language. Think about it. Every single concept, every model, every prediction, it's all written in algebra. That's the big idea we're going to unpack today. Okay, so let's get into it. Let's start learning this supposed secret language. And just like learning any new language, you got to start with the basic vocabulary, right? So in algebra, our first two words are variables and constants. Let's break down what those actually mean. Okay, so the main thing to get here is how they're different. A constant is, well, it's constant. It's a fixed number, like 5 or pi. It never ever changes. But a variable, that's our x or maybe something like price, that's just a placeholder for a value that can change. It's dynamic, it's flexible. And this right here is exactly why variables are so critical for AI. Just think about it. When an AI model looks at data, every piece of information, we call them features, like a customer's age or the size of a house, those are all variables. Because, of course, the age and the size change for every single person or house. Okay, so now that we have our words, we can start putting them together to form phrases. And that's pretty much what an algebraic expression is. It's just a combo of our new vocabulary, variables, constants, some math symbols. But, and this is super important, it's not a full sentence yet. The key thing to notice? There's no equals sign. Let's actually build one real quick. Super simple. We'll start with a variable. Let's just call it x. Then, let's multiply it by a number. We'll call that a coefficient, say 5. So now we have 5x. And to finish it off, let's just add a constant, like 3. And boom, 5x plus 3. That's it. A nice, simple algebraic phrase. All right, so we've got words, we've got phrases. You know what comes next, right? It's time to start writing full sentences. And in our new language of algebra, we call those equations. So an equation is where we finally get to use that equal sign. It's basically a statement that says two things are true. It says the phrase on the left side is worth the exact same amount as the phrase on the right. The best way to picture it, think of a perfectly balanced scale. And if you want to keep that scale perfectly balanced, there is one single, unbreakable law you have to follow. We call it the golden rule of algebra. And it's simple. Whatever you do to one side, you have to do the exact same thing to the other. You add 5 to the left, you got to add 5 to the right. It's all about keeping things in balance. Okay, let's see this golden rule in action. Say we have this equation. Our goal here is to figure out what x is. We want to get it all by itself. So we just undo all the math, but we have to do it to both sides of our scale, right? First, let's get rid of that 4 by subtracting it from both sides. Cool, now we have 3x equals 15. Then just divide both sides by 3. And there we have it, x equals 5. Simple as that. So why are we doing all this? Why does this even matter for AI? Well, because this is basically what machine learning is. Seriously, an AI model is really just a super complex equation, and the whole learning part is just the computer's process of solving for the unknown values, like that W for weight we see here, that make the equation true for all the data it's looking at. Okay, this brings us to the grand finale. We've learned the words, the phrases, the sentences. Now we're going to put it all together and see how a real AI model is built using this really powerful idea called a function. So what's a function? It's just a rule. That's it. For any input you give it, it spits out one and only one output. The vending machine analogy is perfect for this. You punch in code C4, you get chips. Every single time. You'll never put in C4 and get both chips and a candy bar, right? It's always one specific input, one predictable output. And here it is. This is the big aha moment. When you strip away all the jargon and all the complexity, pretty much every machine learning model is a function. That's it. It's just a really, really sophisticated function that has been taught the perfect rule for turning your data into a useful prediction. Let's make this super concrete. Imagine a model that predicts house prices. The inputs, those are our variables, right? Things like the house size, the number of bedrooms. The function, well, that's the model itself. It's that algebraic equation we've been talking about. And the output, you guessed it, the predicted price of the house. It's really that simple and that powerful. So there you have it. This secret language of AI. Turns out it's not so secret after all, is it? By just getting a handle on these simple building blocks, you've already taken the first and honestly the most important step on your journey into understanding AI. Let's do a quick recap of our little language lesson. The variables? Those are the basic words you use to describe your data. The equations? Those are the sentences that you write to explain the relationships in that data. And the functions? Those are the big, powerful stories, the actual predictive models that you build from all those sentences. So we'll end on this thought. You now genuinely understand the basic grammar of artificial intelligence. It's a language, but it's not made of letters, it's made of logic. So the only real question left is, now that you know the language, what are you going to build?